Thank you very much, and good morning, everyone. I'm going to start my talk with a picture of a chandelier. And I'm doing this because it struck me that this is a good metaphor for collective inspiration. A good idea, but not just by one person with a light bulb, but a whole group of people. This is what happens, and my talk is about how we garner the collective wisdom from research and science that we heard something about in the last session, and use it to respond to the collective questions and knowledge needs of those working in policy and practice on conservation of biodiversity. So here you can see we were lucky enough to capture a digital image of the Eureka moment itself. This picture was taken at a really spectacular venue, actually, the Fishmongers' Hall on the River Thames in London. And what you see here is a group of people, a very mixed group of business people, government, regulators, and researchers, discussing what we really need to know to make the aquaculture industry in the UK, that's fish farming and shellfish, more sustainable. Over the last 6 or 7 years, along with Bill Sutherland and a number of colleagues at University of Cambridge here and elsewhere, we've had several meetings like this, bringing together mixed groups of people to collaboratively identify research questions or knowledge needs. You've heard something about these exercises already yesterday. I'm going to just talk briefly by way of introduction about 5 exercises which we've had since 2010, which were all focused on different aspects of sustainable food production. So we did something like this for pollinators, we did it for aquaculture, for agriculture, for global agriculture, for food security, and we asked this question: what do we need to know to make food production more sustainable? Bringing together these diverse groups of people. Now last year, Rebecca Smith, who works here with us, a colleague, spent some time collating all these different questions from all these exercises, and there are actually 286 important questions about how you make food production more sustainable. She sorted all the questions and knowledge needs into a driver pressure state impact response framework, according to what kind of question they were. And this is what all those questions look like, how they apportion into the different categories. So what you see, there's a section here which is underlying science, and that's questions that are just about how the system works, that don't really fit into the driver pressure state impact response. But there's a small group of the questions which are about drivers. For example, what influences an individual's consumption of plant-derived foods, which is about diet and how that changes sustainability of food production. An impact question might be, what is the risk of mass migration arising from climate change, and how will this impact on agricultural systems? And a response question, that's about what we do about it. How much land should be left as natural habitats to provide ecosystem services in agriculture, for instance? Now, I'm really quite pleased that so many of these questions turned out to be about responses, because these are groups of people are trying to do something in the real world. If you ran a similar exercise for what's in the scientific literature, I think you'd see some very different portions. And you would see most of the research was in this area. As part of the Conservation Evidence Project, we've been trying to gather information just for the responses questions, what works in conservation. And so what Bex did was look at how many of our answers and collated evidence can respond to these particular questions of the 286. And she found that 12% of all the questions had already been answered to some extent by our collation of evidence. You can find this information on the Conservation Evidence website if you're interested in what those particular questions were. But the point of showing you this is, first of all, to give you an overview of the kind of questions that policy makers and practitioners ask, in this case in sustainable food production, but also to show that we've just started in collating the evidence to get the right answers. And I can't stand here and say that these responses that we have answered have all been used by the people who posed the questions. Some of them might have been. I hope they have. There are also all these. And it's important to say that this is just a snapshot in time, and these are the questions from a particular set of groups of people. They change all the time. There's a real diversity of different knowledge needs in the policy and practice community. One of the questions we do have an answer for is, what are the alternative sources of protein and oil for use in aquaculture feed? And I was personally amazed to find that we have a series of well-summarized sets of evidence on the effects on farmed fish of different types of alternative oil as feed source, as opposed to fish oil. So that's just to show you how useful this process can be. my talk is about how we can better link the policy and practice questions, that great array of questions, to existing evidence. And I'm just going to talk through 3 different mechanisms that I've personally been involved in. There are obviously other mechanisms, and go through what makes them, what's strong about them, what makes them good, and what contexts do they work well in. So that's decision support systems, national or international assessments, and active knowledge exchange mechanisms. Decision support tools. You will have seen, if you were in the last session, Andrew Pullin putting up the hierarchy for organising evidence, environmental evidence or any evidence, with studies at the bottom, systematic reviews playing a very key role, then summaries. Decision support systems we would put at the top of that. They're very close to the decision-making context, but what we hope is that a decision support system builds upon an unbiased view of all of the scientific evidence that's relevant to that question. My example of that is something I've been working on for a couple of years, and it's there's something called the Cool Farm tool, which is currently a greenhouse gas calculator, and it's used by member companies of the Cool Farm Alliance, who are a set of pretty important food and agri-food companies, either retailers or suppliers, and they use it in their supply chains to measure the sustainability at farm scale of the operations globally. So we've been building a tool which does something similar for farm biodiversity. It's called Cool Farm Biodiversity. I'll take you very briefly through how it works, because I think it's an example of a decision support tool which actually builds on unbiased assessment of evidence collated. So it has a structure like this. The structure is taken from a proposed structure for biodiversity metrics, which was decided by something called the Sustainable Agriculture Initiative. So the structure here actually comes from industry. This is what they thought would work for measuring biodiversity on farm. And you break the practices down into 4 different components: your products, the practices on farm, small and large natural habitats. And then the tool is based on the actions you take. So it's really giving you a measure of how well you are looking after biodiversity on that particular farm relative to how well you could if you did all the things you could possibly do that would be good. So under each of these components, there's simply a list of practices, which are the things which are recommended or known to work by the farm advisors and the conservation community. But the problem with biodiversity, and taking a metric for biodiversity, is that it, unlike greenhouse gas emissions, it's very difficult to put it all into one single unit. This is a really serious problem. So what we've done with this tool is we have an overall score that's your general biodiversity, what would be expected to be your general impact. But we have separate scores for different components of biodiversity, which are selected by a group of stakeholders as the things which would be important in farm biodiversity for that geographic area where the tool applies. There's actually 11 things in the tool at the moment. It applies to Northern Europe, so as broad as we thought we could make it. It's things like farmland birds, beneficial insects, soil biodiversity, arable flowers. And you get a separate score for each of those. Now, how we incorporated the evidence into this is based on the synopses that John was talking about earlier with the BAT synopsis. In each of these, we have a whole summary of evidence for all the different actions you could take, and we've made an assessment using groups of stakeholders and experts, mixed groups, who go through something called a Delphi process, which is an iterative process of scoring, usually anonymously. They do this online, and they look at the evidence for each action, and they score it according to its effectiveness and its certainty. Then they see everybody else's score, and they are given a chance to score again anonymously. So you have a process, I'm sure we'll hear more about this kind of process, of gathering the expert opinion in a joint and collaborative way, but everybody's individual contribution to that is anonymous, so you lose the social bias that you get when people just talk. And using those scores, we then put the interventions into categories. This book will provide you some more information on this, which you can download for free online. But based on the certainty and effectiveness scores, after the rounds of scoring, things are either beneficial, they definitely work, every time they've been tested they work, there's really good evidence for this, or some of these other categories, some things we don't know, some things there's quite high certainty that they don't work very well. And in the Cool Farm Biodiversity tool, we've simply weighted the scores. We've added 2 points if it's in the beneficial category, and we've taken out actions which really don't work, which we know quite well don't work. So there's a weighting which is based on the body of scientific knowledge on what works on farms to enhance biodiversity. And you get results that look like this. So you get some speedometers at the top. This is how you do compared to the maximum possible. And you get a different score for each element of biodiversity. So if your objective is particularly focused on beneficial insects, you might be trying to improve this score here. These are some of the partners of the Cool Farm Alliance who will be using this tool as soon as it's launched, which I hope is going to be in the next month or so, in supply chains which are quite massive. So the impact of this is potentially huge on directing farmer practices towards things which are known to work and away from things which are known not to work. And I would argue that decision support tools represent collated evidence well when there's a specific question which is widely and repeatedly addressed. When the user groups are involved in developing and designing it, and they're willing to fund it. This is super important. Decision support tools, as has already been said in this conference, often stop at the point where you've got the tool built and it's all lovely and software. The software is fantastic, but nobody actually ever uses it because the people who would use it weren't asked in the first place what it was they needed to know, or what decision they were making, or what context it needed to be in. So that's a really important point. They work when the relevant evidence can be converted somehow into simple numerical or visual formats, as I've just shown you with the readouts from this. And when the link to underlying evidence is transparent. And that's what we really lack in a lot of decision support systems. There might be some evidence, but it's quite hard to find out where it came from. My second example is national and international assessments. There are quite a few of these, increasingly. You're probably familiar with the IPCC, the Intergovernmental Panel on Climate Change. This is a global process for assessing science on climate change. It's been going on for decades now. It's become enormously influential. There is, more recently, an intergovernmental science policy platform on biodiversity and ecosystem services, which is in some ways similar to the IPCC, but also broader. There are national assessments, such as a very famous one, the UK National Ecosystem Assessment. Now, I've been involved in one of the first reports that came out of the BES process just a couple of months ago. It was launched in Kuala Lumpur in Malaysia. So I can talk a little bit from the inside about what these processes actually involve and how they translate collated evidence into use of science in policy and practice. What happens is, for an international assessment and also for a national assessment, you have a whole group of scientists who are nominated, in this case nominated by governments, to be the experts that will make the assessment. And those people meet and they discuss and they write a report and hopefully they read the evidence and hopefully they search the databases of evidence in a rigorous way and they report what their research methods were, which doesn't always happen, but we're trying to make that process more open and transparent. And then what happens is that the technical report, which is often huge, many hundreds of pages, is translated into a much smaller document, which is called a summary. And the summary is put before governments in the case of an international assessment. So for the BES, there are 124 governments who are members, and they will send delegations to the meeting, and the summary for policymakers is their document. It doesn't belong to the scientist. It's a co-produced document between science and policy. And they will go through that document line by line and agree or disagree with the content. And the scientists will be there at the same time to say whether any changes that are proposed reflect accurately the science or not. So this is a true science policy process that comes up with a written assessment of the science. And in the course of that, you will have some really intense discussions between scientists and policymakers. So what you see here, if you're in the pollinator research community, these two guys you might consider to be big cheeses. That's Simon Potts and Koos Biswayer. But actually the really big cheeses are over here, because these people are the 4 delegations from the French government. And in this conversation, there's some very specific point about what was in the research being intensely debated. And we came to an agreement. So this is a really interesting point in time. What you see from these assessments after all of this work, and the pollinators report took about 2 years or just over 18 months to produce, is usually just either a single sentence or a single figure. That's what's communicated. This is something that came out of the 5th assessment report from the IPCC. Here you see greenhouse gas emissions or tons of carbon dioxide equivalent. This is what's going to happen. This is years. These are the different emission trajectories. And this is the temperature change we expect according to those different scenarios over the next, looks like about 9,000 years. And that's what people take home, all of this work and all of this assessment into this single diagram. Similarly, many of you will have seen this before. This is the diagram that everybody saw after the UK National Ecosystem Assessment, which has been so influential. And here you see different types of habitat, different services, and what I see from this is that pollination is going down, and we know that very well. There's quite a high certainty that pollination is experiencing some decline. So again, a single diagram. From the pollinators assessment, you might find that you see a map like this. This is the map showing the pollination benefits in US dollars per hectare all over the world. And it shows you that there's some areas of the world where there's quite a high pollination value. Another diagram you might see, I think you're probably very likely to see from the pollinators assessment, is this one. This has taken a lot of discussion and talking, and it's showing what we know about sublethal effects of a group of pesticides called neonicotinoids on individual bees at different levels, so molecular level, physiological change, organism change, different levels of exposure to neonicotinoids. If it's green, there was an effect found. If it's blue, there was no effect. The important bit about this figure is this orange band across the middle, which shows you the residue levels that have been found in the real environment. So if the green is in the residue level band, we've got a problem. So what I would say about scientific assessments is that they represent collated evidence well when there's a broad issue of very strong interest politically. There's a lot of public money available for the assessment, and I'll come back to this. The evidence can be summarised effectively in simple numerical or visual, really important, visual formats. We don't always know this until the end of the assessment, and it's usually tacked on at the end. It's not something we think about at the beginning. It's all the assessment goes on, then we have a result, then, oh, we need a visual artist. We need to convey this. Thank you. And they work well when methods of review and summary are transparent and rigorous. So my final example is active knowledge exchange mechanisms. There are many of these. One of them, I would say, is the SAGE group that John Beddington was talking about yesterday. I'm involved in a quite new project called Eclipse, which is a knowledge and learning mechanism for the European Commission with a mandate to translate knowledge on biodiversity and ecosystem services into real questions made by policymakers. And the structure of this Eclipse project is that knowledge requests come in, they're dealt with by a working group, and then a specific set of methods is taken to address that knowledge need. And the whole project draws on a network of networks. It's very well linked in with all the biodiversity and ecosystem service experts in Europe. So it coordinates and communicates with all these other efforts that are going on, and it makes the bridge between that and the various and diverse questions that are coming through all the time from the policy community. Our first request in the Eclipse project has been this one: how should the effectiveness of nature-based solutions at adapting to climate change be measured? So this is interesting. It's a response question. It's relatively difficult, but we will go through the process of working out what to do and how to respond to that, using the collated evidence as well as we can and being transparent about the methods. So these kind of knowledge exchange mechanisms represent collated evidence well when many different questions continually arise, which of course is the case. When there's money available to fund the mechanism, I'll come back to that. When available methods for synthesis are well described and transparent. So let's go back to the question I started with. How can we better link policy and practice questions to existing collated evidence? Remember, all these questions are coming from a whole broad set of people, a whole broad community, and there are many different types of question. I would argue that these three mechanisms I've talked about can all be applied to any of these kind of questions relatively easily, as long as you're prepared to spend the money. And what does it all cost? I have been, over the last few years, gathering examples of costs and putting together the costs of some of these exercises so I can show you how much I think they cost. Decision support tools, quite difficult to get a single figure, but they cost a wide range, £400,000, £4 million per tool, depending on how much time and effort goes into them. International assessments, the budgets for IPCC and IPBES are about £3 million a year. Knowledge exchange mechanisms, the Eclipse project is costing about £600,000 a year. Now, these are the mechanisms to take the collated evidence and link them to the policy and practice questions. They rely on the evidence being collated in a rigorous and unbiased way. So you also have to take into account these costs, the cost of a systematic review, up to £200,000. The cost of summary and assessment of evidence, like what happens in the Conservation Evidence Project. These costs might look like quite big amounts of money, but actually they're not huge. because the European Commission Horizon 2020 budget is spending £8 billion a year on scientific research and is trying to incorporate some of these mechanisms. I think we need to just keep saying this again and again. This stuff costs money, and we need to spend the money to make sure that the science is continually being used. So my take-home message is, to save biodiversity, we don't just need good science. We also need a variety of mechanisms to respond to policy and practice questions. We need public and private funds to support these. And we need methods of collating and communicating evidence that are well-developed, transparent, and widely understood. I'm going to leave you with a photograph taken on the top of this building so that you can have a good idea of where you are. And I would just like to thank all of these people, some of whom were involved in the Cool Farm Biodiversity Tool Assessment, and Bill Sutherland, Rebecca Smith, and Jessica Walsh, who've been involved in a lot of this thinking over the years. Thank you for listening.
Thank you, Lynn. As having been on the Darwin panel for 6 years, I'm glad to see that some of your costings come in at that lower level that Darwin supports. So we'll take a couple of questions. Can we come down at the front this time? Thank you, Camilla.
Thanks, Lynn, for the very interesting talk. Could you expand a bit more about the value of having the industry, the private sector, involved in these kind of initiatives? And how they did in this case, for example, got involved from the beginning? What was the objective of all that industry brands there that you showed?
Okay, thank you for the question. I would say two things. The first is that the value of having industry comes from the value of having all the different interest groups involved in any discussion like this. Not just industry, but also consumer groups, and also the conservation NGOs, and also government. And there's research to show that if you involve all the different interest groups, you get a better decision in the end. And the other thing is because, for instance, in sustainable food production, or indeed in biodiversity conservation, industry has a massive clout. It can really change things on a huge scale. If a global food supply chain decides it's going to tell all its farmers that what you really need to do is this, the area of land on which that happens is much bigger than we could achieve in the conservation community. So that would be my other reason.
Thank you. One more question, also fairly near the front. Thank you, Karen. This one.
Hi, Clive Mitchell from Scottish Natural Heritage. I'm interested in, I guess, some of the bias that's inherent in some of the techniques that we're talking about. So how, for example, you capture indigenous or vernacular or local knowledge in the assessments and the techniques that you've described. And in some ways, I think Malcolm was talking about some of those things in the very first talk this morning, the way in which reserve managers use their intuition and experience as much as anything to inform the actions that they take.
I'm really pleased you asked that question, because the IPBES has been blazing a trail in incorporating indigenous and local knowledge into international assessments. And because I've been involved in one of the first assessments, I've been very closely involved in that process. It has been very difficult, but I think that there is now a good process. What you have is the indigenous and local knowledge is local. By definition, it's very context dependent. It comes from a particular group of people, and they own it, not the scientists who, scientific knowledge is available to the public in theory, whereas indigenous and local knowledge actually belongs to the knowledge holders. The process that has been put together through the first few years of IPBES is to start with something called a global dialogue, which reaches out to all the possible knowledge holders in a particular area, brings them together, develops case studies and stories that might be examples of relevant indigenous and local knowledge, follows them up with a bit more detail, has them validated by the local knowledge holder communities, and then puts them in the context of all of the scientific knowledge. What we find for the pollinators assessment is that there is local and indigenous knowledge in areas where the scientific knowledge is quite poor, for example, in husbandry techniques for stingless beekeeping, for instance, or even basic ecology of stingless bees. So there are some examples where those two knowledge systems complement each other very well. You will also find examples where they contradict, and I don't think we've quite got to how we're going to deal with that yet. But there's a lot of progress going on, I would say, and I think it's a really important point.
Thank you very much, Lynn.